Alright, so let's start over. So HgBr2 yielding HgBr2. Everything's balanced. So this is a limiting reactant problem. So I'm going to go ahead and just do the problems from Hg's perspective, which is mercury, and predict how much I'm going to form this one. Then I'm going to do the same thing, but using Br as my limiting reactant, and see which one's going to give me the product, right? And see which one's a limiting reactant. So Hg, I have, I thought I worked it out. Oh, there it is. Okay, well, I guess I didn't do base effect. So here's 10 grams of mercury. Mercury has 200.59 grams per every 1 mole of mercury. Now I'm going to look at the molar ratio. It's 1 to 1, reactants to products. So for every 1 mole of mercury that I get, I'm going to get 1 mole of HgBr2. Now, it's asking for the mass, so I'm going to go ahead and convert that. So I figure out that HgBr2 has a mass of 3, for every 1 mole of HgBr2, I have 360.39 grams of it. Oops, grams of it. Okay, I'm just going to go ahead, cancel out the units to make sure that I got everything canceled out. So I got grams of mercury canceling out, moles of mercury canceling out, moles of HgBr2 canceling out, and the only thing I have left is grams of HgBr2. Okay, I'm not going to do the calculation just yet. Now, Br2. I'm going to do the same thing. I'm going to predict how much product I'm going to form using Br as my limiting reactant. So I'm going to assume that I have 8.80 grams of Br2, and I do the math and I get 79.9 times 2, because there's diatomic, grams of Br2 for every 1 mole of Br2. Molar ratio is 1 to 1, so for every 1 mole of Br2, I have 1 mole of HgBr2. Same thing, the mass stays the same for HgBr2, so for every 1 mole of HgBr2, I have 360.39 grams of HgBr2. Let's cancel out the unit. Grams of Br2 cancels. Br2 moles cancel. Moles of HgBr2 cancel, and you're left with grams of HgBr2, which is what you want. Joy, what's up? Diatomic, so 79 times 2. Cool? Question, Trey? HgBr2. Yeah, because that's a product that you just look for, remember? So for every 1 mole of HgBr2, you have 360.39 grams of HgBr2. Question. I'm recording this already, huh? Yeah. Imani. Okay, yeah, so you do this math, right? Okay, this is the math. I'm not going to actually do the math because I have the answer. When I do the math, remember, I just want to make sure you know this. This is over 1. So if you do the calculation for top one, you do 10 times 1 times 1 times 360.39 divided by 200.59 times 1 times 1, right? But 1 doesn't really matter. So remember, if it's on the top, you multiply all the way through. At the bottom, multiply all the way through. Then you divide the top number by the bottom number. We did part 1 of the limiting reaction. Okay, so when I do it, I say that there are 19 grams of HgBr2, and the excess reagent is Br2, which makes Hg my limiting reactant. Now you want to figure out how to find excess reactants, right? So I'll show it back up. 19 grams is rounding error, right? Okay. All right. So do you want me to actually put in the calculator?
Yeah.
Which one? For mercury, I get product of what? 18.02, and the other one I get? 19 what? Say it again. 19.85 grams. Now this is HgBr2. You always choose the one that's less, right? So that means this is the actual product that this is going to form, which makes Hg your limiting reactant. Limiting reagent, limiting reactant. Correct. Okay, if that's the limiting reactant, which one is the excess reactant? Br2, right? So if I'm physically asking you, I want to know how much is going to be left over. Okay, now, to figure out which one, how much is going to be left over, I have to go from my limiting reactant to the excess. So let's figure out how to do that math. And Hg is my limiting, so I'm going to erase this. Yeah, that's fine. Good? Yes. Okay, so I'm going to erase this for now. So the question is asking, what mass of reagent is left unreacted? Okay, what is the mass of Hg that we're using? How much is excess is left over? What was it? 10.52, right? 56 grams of Hg. Now, all I'm trying to figure out is if I'm using up 10.56 because that's my limiting reactant, how much is Br2 that I'm going to use up? How much is there to begin with? 8.80 grams is there to begin with. But let's see how much I need for Br2 if I'm using 10.56 grams of Hg. So again, convert this to what? Br2. Moles. Grams of mercury gives me 1 mole of mercury. For every 1 mole of mercury, I'll be using 1 mole of Br2. I'm going to convert that again. For every 1 mole of Br2, I have 79.9 times 2 grams of Br2, right? So when you do the math, what do you get? 10.56 times 79.9 times 2. 79.9. Okay, table. Yes. Okay, so I got 8.413 grams of Br2. Now, this is very important. Think about what that number means, right? I'm using 10.56. By doing this math, I figured out this. If using 10.56 grams of mercury, then I'll use up 8.413 grams of Br2. Okay, but that's the only amount that I'm using. I had 8.80, so to find how much is left over, I'm going to take this and subtract from the original amount, which is what? 3 something, right? 0.387. That is how much? 0.387. And that's how much is left over, unused. Unused. Okay. So I just subtracted from what I had, 8.80 initially, what I used up, 8.413, what's left over. Trey. This is Br2, diatomic. All right. Keep talking. Remember, this is recorded, so I'm going to just pass it through, okay? Next up, now it's talking about density. All right. Density. You want, every time we were talking about mole ratio, what do we convert grams to? Moles, right? Okay. But here, they give us the volume and the density. So let's see how we can manipulate that. So let me go ahead and wipe over white. Okay, I'm going to go, it's the same limiting reactant problem. Okay, what mass of HgBr2 is produced from the reaction of 3.64 milliliters of mercury? So now I have, for mercury, 3.64 milliliters of mercury, right? For Br2, I have 3.64 milliliters of mercury, Br2. Okay, I have volume. it does not say anything about gas, so we can't use the whole STP at 1 mole is equal to 22.4 milliliters, right? But what do I have? Density. So if you look at the densities formula, it's grams over milliliter, right? I need to convert this number to moles. So what does this and mole have in common? Grams. So I need to get this guy into grams, that I can use the grams to go to moles, right? So then if I have milliliters here, I'm just going to multiply the density, which is 13.6 milliliters grams per milliliter. What happens to milliliter? So now what do you have? Grams. Now what can you do with that? Convert to moles. Just 200.56 grams for every 1 mole. Do the same thing with the limiting reactant. 1-to-1 ratio, find the mass of HgBr2. Let's see what we did again here. Br2 now has a density of 3.10 grams over a milliliter. So I'm just going to simply multiply 3.10 grams over 1 milliliter. What cancels out? Milliliters cancel out. Now I'm left with grams. That means I can use this to go to moles of Br2. Then I can figure out the moles of HgBr2. Then I can figure out the grams of HgBr2, which means I can figure out which one's limiting and figure out how much product I'm making. And the answer ends up being 25.45 grams of HgBr2 will be formed if you use the limiting reactant. Question. Alright. Do you guys actually watch the video?
Yes. I watched it back in January.
Alright. So. I remember that. Alright. So. This is what I'm going to do. If it's a combustion reaction, basic rule of thumb is that if you have a combustion reaction, it's always going to be carbon something something. So in this case, they actually tell you it's got carbon, it's got hydrogen, and it's got oxygen, right? Combustion reaction always follows this formula where you have this guy plus oxygen, diatomic molecule, reacts with carbon dioxide and water. Okay, this is just like the guided notes problem. Okay, let's write down the information first. They tell you that there are 21.79 milligrams of this guy, and then that combusts to give you 46.18 milligrams of carbon dioxide and 7.10 milligrams of water. And they tell you the molar mass of terephthalic that acid is 166 grams per mole, right? Okay. I have carbon dioxide. That's a 7. Carbon dioxide. All of that carbon, I can assume, make up all of the carbon here. So the number of moles of carbon in CO2 is the mole of carbon in this organic compound. And all of hydrogen is same thing here. But the problem is, now we got this oxygen, right? But let's not worry about that exactly. Let's not worry about that for now. But I'm going to go ahead and figure out how many moles of carbon and hydrogen there will be, respectively, okay? So, I'm going to raise the top part so we can have some more room. Yes, ma'am? How much is made and how much I have.
Okay, so are those
given to you?
Those are the ones that you give me?
Yes, exactly. Okay, so can we make sure you do the homework at home before you come to my class? That's true. I know. You should show it to your mom. Okay, so carbon dioxide, you have 46.18 milligrams. Okay, remember I showed the trick of canceling some millis? Not going to worry about it, right? So if I have 46.1 milligrams, I have 44 grams of, for every 1 mole of carbon dioxide. for every 1 mole, for every 1 mole of carbon dioxide, how many moles of carbon do I have? What? Mole. I have 1 mole of carbon. Right. Okay. Now, I'm going to leave that milli by itself because it's milligrams, right? So I'm just going to cancel out the grams. Grams, moles of carbon dioxide. I do the math and I get 1.05 millimoles of carbon. Yes.
What did you do? What did you do? So what did you do? Convert to carbon? And that just was the question, right? That's not like a specific conversion.
Okay, for water, quiet down please. I have 7.10 milligrams for every 18 grams of water. I have 1 mole of water. But Trey, how many moles of hydrogen do I have in here?
2 moles.
Yeah, 2 moles.
For every 1 mole of water, I have 2 of the hydrogen. So I say for every 1 mole of water, I have 2 moles of hydrogen. Jesus, stop emailing me. Okay, so, thank you, Derek. Now I have 0.789 millimoles of hydrogen, correct? Okay, I figured everything out except for the part where I have to work with oxygen, right? Okay.
That is 7 plus 9.
7, 8, 9.
So 7 what?
7, 8, 9, like every number.
No. Yes.
Okay, so those numbers, when I have 1.05 millimoles of carbon, that's the amount of carbon I have in here. So I have 1.05 millimoles of carbon, and I have 0.789?
That's a hydrogen or hydrogen C. That's hydrogen, not oxygen.
Oh, I'm sorry. Wow, my brain. 0.789 moles of hydrogen, right? Okay, millimoles. They're all millimoles, right? Okay, now, can I convert moles to grams? Can I convert moles to grams here?
Yeah.
So that means if I know the mass of carbon and I know the mass of the hydrogen and I know the mass of the total thing, can I figure out the mass of oxygen? So this is what it looks like. I'm going to convert 1.05 millimoles to grams by doing this. Times for every 1 mole, I have 12 grams. But now, only the moles will cancel out. What's the unit that I have? Milligrams. Periodic table.
This is easier doing this one.
Absolutely. So you don't mess up the thousands and the zeros and all that. For 1 hydrogen, 1 mole of hydrogen, you have 1 gram, so moles cancel out. You're left with milligrams. So when you do the math, I didn't write it down. Can someone do the math? Yeah. 4.6? Alright, say one person say Emerson, what do you 12.6 milligrams of carbon. How about this then? 0.789 milligrams of hydrogen. Okay, now, exactly. So, when I add carbon, 12.16 milligrams, plus hydrogen, 0.789 milligrams, plus some amount of oxygen in milligrams, I should get what? 21.79 milligrams.
Wait, you said this should be the total milligrams of the which was 21.
Alright, so when you do the math, how many grams of oxygen do you have? 8.4 milligrams of oxygen. Wait. So, I just figured out how to find the moles of each component. Do you understand how I did that? Okay, now, it becomes a basic empirical formula problem, right? But I can't work with milligrams of oxygen. What do I have to do? Convert to moles. So I'm just going to do the same thing for 16 grams of oxygen. I have 1 mole. grams cancel out. Now I have millimoles again. That's fine because everything else is already in millimoles. So when I do this, I should get 0.525. Is that what you got? 5 to 5 millimoles of oxygen.
Why did you take these millimoles and put something in there?
I couldn't.
You couldn't?
I have to turn it to moles because I'm now looking for empirical formula. You can't, but I already have it in grams. But that's fine. If you want to do grams, that's fine too. Okay, now, hold on. I'm going to do some housekeeping here, okay? I want to write down how much carbon has. So carbon, I have 1.05 millimoles, right? Oxygen, I have 0.525 millimoles. And hydrogen, I have 0.789 millimoles. Okay? Alright, now, I don't find this equation useful anymore, so I'm going to make somewhere, I'm going to erase this, okay? So everything I need, I have down here. Everything you need, it's already in the video, so I'm going to erase it. Okay. Now, this, I have three numbers, C, O, and H. To find empirical formula, what do I do? Divide by the lowest number. So out of the three, which one do I want to divide by? So I want to divide by the number of moles of oxygen, which is 0.525 for all of them. When I do that, for 1.05, I get 1.33, right? Am I right? No, it's 1.5. 1.05. Oh, I get 2. Sorry, 2. For 0.052, I get 1.789. I get 1.5. I got it. Yes, okay. So we're going to multiply these by 2 to make it a whole number. And I get C4O2H3. And that is your empirical formula. Does H come before O? Doesn't matter. Yes, usually, but doesn't matter. Yeah.
So because it's a millimole, you don't have to convert it or anything?
No, because you kept, as long as you keep your units consistent and you figure out that you carry on the millis and all that and keep it consistent, you don't have to worry about it. Exactly, because it's just a ratio. Now, C4O2H3. Now, but look at the formula. Do I need to go over that? Okay, good. Exactly. So, let's go to the next problem. Okay, so they tell you the molecular formula weight is equal to 166 grams for every 1 mole, right? This is the mass of molecular formula. This is my empirical formula. So find the empirical formula's weight by doing 12 times 4, 16 times 2, plus 3, that's 48, that's 32, 3 plus, I get 35, and then what do you get? 80. 88. What? 83. Good. Okay. So, to find the molecular formula's factor, they have to multiply by, right? You take the molecular formula's weight, which is 166, divided by empirical formula's weight, which is 88. That's twice as big. So, need to multiply all these by 2 to get my molecular formula, which is C8O4H6. They give it to you. Yes. They have to give you the molecular weight. No. I'm sorry, hold on. I can't hear you. Ryan, what? Always molecular weight divided by empirical. Molecular weight's going to be bigger, always bigger. That's 2. You multiply each of these atoms by 2. So that's why you get C8O4H6. Mariah. Yes. Okay, we need to move on because I have time for like 2 more problems. Alright. Is this number 3 or 4? That's
number. That was easy.
Yes, it
Well,
was.
except for part B.
All it's all molecular.
Do part B.
B is B.
Multiply the empirical formulas compound by 2 of these. Double all the atoms. Double them. Okay, so since Gabby seems to be the only person that's talking about this problem, I'll just
Gabby
do.
and Allison. So she doesn't
Okay,
know.
so I got it great. Good job. Yay. Alright, listen. Okay, so what is the molar mass of cumulant? We already know how to figure that out, right? Just do C times 21, blah, blah, blah. Add it all together, that's molar mass.
It's 360.
Okay, I know. Alright, how many moles of this guy, molecule, what? Oh, okay, I got it. Okay, I was like, what? Okay, so I didn't work this out, but let's see if I'm understanding this correctly. It should be 175 milligrams of C21 H30O5, right? And I have 362 grams for every 1 mole. Grams cancel out. For every 1 millimole, remember, because this is going to give you millimoles, right? You need to convert it to moles. Yeah. C4? C21. Sorry, that handwriting. Oh, God. So, how many millimoles are in a mole? 1,000? There are 1,000. Oops, sorry. I wrote that wrong. Okay, let's do that then. 2 grams. There are 0.362 milligrams, right?
No, gram.
It's alright, I'll just do it your way.
Just convert 175. Convert 175 into.
My computer's lagging, okay? Give me a second. Alright, it's not working.
Why is Gabby so he doesn't do that shit.
No, if you knew your prefixes and knew the conversions, we wouldn't have to deal with this. Yeah, I want to.
At least save it before you start showing.
Okay. Alright, we're back. We're back. There it is. Jesus. Okay, so you probably got all of that conversation, so enjoy that. Yes. Okay. No, I have to. Oh no. Alright, right. Okay, so let's start over. If it makes you sleep better at night, let's convert this to grams. 175 milligrams, the same thing as 0.175 grams. Do you agree? Yes. Okay, so 0.175 grams of blah, 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 I'm not going to write it all, divided by 362 grams for every 1 mole. So, can someone put that in a calculator?
I can just go ahead and turn it into molecules.
So that's 4.83 times 10 to the negative 4 moles. So I don't know why you didn't get it right. That's the answer that I got.
Wait, where's my work?
That's the answer. It's not, it's saying.
No, it's no.
Use different numbers for everybody.
It's not. I checked.
Because B is a different number. A is the same for everybody, but B is different.
No. So maybe try writing it out. That might work. Okay, I have 5 more minutes. I want to do the next one. No, you could have done it with milligrams as long as you write your answer in the right moles. Okay.
7 and 8.
I don't have time for both. Okay, so this is 7. This is 8. 8 is exactly like number 3 that we did empirical formula and molecular formula. Would you prefer to do a short problem so we can actually finish it?
No, do 7. Do 7.
This is 7. We have to do this one. Okay. So easy stuff. A compound contains only CH and N. Already reading at it, you're thinking, okay, this sounds a lot like the other ones that you did, right? So what is the first thing that you do? Make the formula. Write the reaction. So let's go ahead and write down the reaction. When you do it, it's going to be C something, H something, N something, plus what? Combustion.
CO2. Oh, O2 get CO2.
And carbon dioxide. So put in the right reaction, right?
Why is it
So you have 40.2 milligrams of carbon dioxide and 49.3 milligrams of water.
She didn't mess up.
What is empirical formula compound? Okay, first of all, you're writing this and you say, okay, I know Missy told me that this is a combustion reaction, and I know the combustion reaction only has components for oxygen, water, and carbon dioxide, right? Right? So that's the part that I know. Looking at it, you say, okay, I'm going to go with what I know, and I'm going to assume that all the hydrogen that I have in water is making up the hydrogen here. All the carbon that I have is making up the carbon here. Nitrogen, I don't know the mass for, but what can I do if I know the total mass? I need to subtract, right? Okay? So, let's do the math together. It doesn't matter, right? Because that's not what the problem is asking. The problem is asking, can you figure out the empirical formula? You can if you just subtract out the mass of carbon, mass of hydrogen from this guy. And we can find the mass of carbon and hydrogen from the moles that you're going to find on hydrogen, water, and carbon dioxide. It's the same exact problem. So, I'm just going to write this out, the map. I'm not actually going to put in numbers. So, I have 49.3 milligrams of water. I'm going to convert that to the moles of water. Then I'm going to figure out what? Moles of what?
It'd be millimoles, though, right?
Millimoles, moles of hydrogen. If I know the moles of hydrogen, what can I find? Grams of hydrogen. I can do the same thing with carbon. I have 40.2 milligrams of carbon dioxide. I can figure out the moles of carbon dioxide. And then I'm going to find what of the carbon? Moles of what? What?
The carbon dioxide.
Moles
We're looking
of,
for H and we're looking for hydrogen, right?
we're looking for carbon, okay?
What? I thought we were looking for hydrogen. Oh, we switched.
Okay, so now we got grams of carbon, right? I know that this guy, grams of hydrogen, plus grams of carbon, plus grams of whatever hydrogen has to equal to what? 42.0 milligrams. When you subtract it out, you'll find this. Now you know the mass of every single component. Now what do? Convert back to moles, and then what? Divide by what, Jonathan? Divide by lowest number of moles, and then you're going to get a number. What do? Now we multiply by factor. Then you got your answer. Good luck today. I will see you tomorrow for reaction prediction. Friday, this is due tonight, so much luck to you. If you did not turn in the guided notes, bring it tomorrow. Nope. Thursday midnight. I got confused.
I love you.